Now, before we can start talking about subqueries, I just want to remind you about the three principal tables that we have developed from the previous sessions. Now, the idea is that this is a company which is organized into departments, which has employees, and employees are able to do transactions. There could be an expense account, or it could be a savings account perhaps. So we have three distinct tables because tables describe a particular object. So the first object we're describing is the department, with the department name, who's in charge of the department, lots of other things maybe about the department. We then have a table employee, which talks about individual employees. We have a unique employee number, we have employee names, we have a government ID, a date of birth, and a department. And the table department is linked to the table employee through this department field, this department column. Then we have the transactions, either the expense accounts or the savings account. And what we have in table transaction, we have the amount, i.e. the monetary amount. We have the date that the transaction happened, which is either 2014 or 2015, the year. There's also obviously a month and a day as well. And we have the employee number. And the table transaction is linked to the table employee through use of the table number. Now note that there aren't any constraints on this version of the database between the employee number in table employee and the employee number in table transaction. So there will be some employee numbers in table transaction which do not occur in table employee, and vice versa. Now, a well-regulated database won't actually have this, but I'm deliberately slightly breaking it so you can see what happens to some of these subqueries we're going to do. So we did talk about in session 3 about putting constraints on these. So let's just remind ourselves about the contents of these tables. First of all, we have the table department. Very simple table, only 5 particular rows. We have table employee. Now this is 1005 rows, and you see the information that we've got here. And there's the department, which links into the table department, as you can see here through this column here. And then we have table transaction, which records the employee number, the date of transaction, and the amount, and it links into table employee through the employee number here. Now, I said that there was no constraints which were effective between table employee and table transaction. And just to show that, let's just stand back and just have a look at the range of employee numbers which are being used in table employee and table transaction. So we'll just have a quick look at the range. So the table transaction goes from 1 to 1125, and table employee goes from 123 to 2004. So there is a disconnect, and I should also say that the table employee, the numbers are not consecutive all the way to 2004. If you have a look at the detail, then it goes 123 all the way to 1125, and then we added 2 later ones. So if you assume that it goes up to 1125 largely, then when we have a look at the min and the max, we can see that the transactions go up to about 1125 and the employees to about 1125. It's just that there's some numbers missing from the beginning in table employee. They are non-existent employees in the transaction table. Right, so that's just a quick recap about the tables, the table structure, and the joins that we're going to do. So now we can have a look at subqueries themselves. Right, here we have a query, and with all of these I strongly recommend you pause the video and work out what it's doing. I'm not going to remind you to keep pausing the video. Generally I'll introduce these at the beginning of this lecture, and you should pause, look at it, work it out. So what happens here is that it's giving all of the transactions for all of the employees. Now, does this mean that there are those phantom transactions you remember that the transaction numbers goes all the way, the employee number goes all the way down to 1. Are those included? The answer is no, because it's an inner join and not a left join. If it was a left join, the number of rows will increase from 2227 all the way up to 2486, which is the number of rows in table transaction. But it's an inner join, and I've specified it expressly. I didn't have to. You can omit the word inner. It's still going to be an inner join. So that's what we've got. So the number of employee numbers start at 123. There's no order by, so it not necessarily in the right order. It just so happens to be in the right order. Now, why won't this work? It won't work because there are employee numbers in table employee and table transaction, and it doesn't know which table we want to take it from, so we've got to specify one of them. So there we go. Notice I'm using select star just to show you the entirety. Now let's say I wanted just those employee last names which start with the letter Y. Have a pause, think about how you can do this. Okay, so we put in a where which goes before the order. So where the employee last name, and how do we do this? Starts with a letter Y, like single quotation, so an apostrophe Y percentage apostrophe. Percentage meaning 0 or more characters. We had to look at that much earlier in session 2. So there we have the list, only 8 people. Now I'm going to show you an alternate way. Note that the characteristics of the way we've done mean that we have to have this join. Because suppose I just wanted to show just the transactions themselves, but wanted to restrict it to those transactions where the employee last name starts with a Y. That could be that. However, I've still got to do this join with the table employee to find out that the employee last name which is in the table employee starts with Y. If I didn't have that, I couldn't use this where. If I didn't have the join, I couldn't use the where. So here's an alternate way which doesn't require the join. Right, well here's an answer, so just pause the video and have a look at it. So we have selecting everything from table transaction where the employee number, now which table is the employee number from? Is it from table transaction or table employee? Well, table employee is not even mentioned here, so it's got to be table transaction, so I don't have to say t.employee number. In, remember I don't use is in, just in, and then open bracket, and here's what we do: 126, 127, 128, 129. I've chosen those employee numbers because I know that those employee numbers have got a last name starting with Y. Now, how do I know that that's the case? Because I've used this query. So select employee number from table employee where employee last name like Y%. So let's execute that. And you can see 126, 127, 128, 129. So all I've done is just type those in the in. But by doing that, I've made those fixed. If employee number 128 suddenly gets married and changes his or her last name, it would no longer be valid. If we have a new employee come in whose last name begins with a Y, then it's no longer complete. So we need to change this in so that it's dynamic, so that it looks at table employee and says, these are the employee numbers, can we have the list? And what we can do is just copy and paste this list directly into the where. So I've got rid of all of the numbers. We still have the brackets. And now I can run it. And so what happens is that this subquery runs, gives us a list of 126, 127, 128, 129, and then it substitutes those numbers and runs the outer query. But with the advantage that if I add a new employee number, this list will update. So one of the advantages of subqueries is that I can just highlight the subquery and run it. So I can work out what is happening in the middle and then go to the outer query and run the entirety. So you can build it up. It's making perhaps debugging of code easier. It's making perhaps your SQL writing easier. We don't have to do a join now. So that's the basis of subqueries. So we're going to expand this in the next lecture. Right, so we've got this query from the last lecture. Now let's add the word not into the subquery. So I'm selecting employee number from table employee where the employee last name not like Y percentage. So in other words, it doesn't start with a Y. Now I'll just remind you that employee numbers in table employee start from 123. So what are we going to see in this inner query? We're going to see all of the numbers from 123 onwards, excluding 126 through 129, as you can see here. And we have those outliers at the end, 2001, 2004. So if I now run the entire query, we have all of the transactions for those employee numbers we just saw. Now, that is a very important statement. It is not all of the transactions in table transaction for all the employees except 126 through 129. Let's just run this again. This statement here limits what table transaction employee numbers we see. So we have a total of 2,219 rows. Now what's going to be the difference if I take this not and put it here? Will there be any difference if it's now in the where clause as opposed to the subquery? So we have where employee number not in the select employee number starting with Y. Well, let's just have a run of this subquery and we see that we're back to 126 through 129. Now let's have a run of the entire query and we've got employee number 1, 3, 4, 6, 8, 10. In other words, all those things which do not occur in table employee. So we are now seeing the entirety of table transaction, which is 2,486 rows, except the 8 rows in table transaction where the employee number is equal to 126 to 129. However, what we previously had where the not was in the subquery was that we were limiting the employee number in table transaction solely to those which are in the table employee, which doesn't include employee numbers 1, 2, 3, 4, 6, 8. So table transaction starts with 1, 2, 3, but this where limits it to those which are in table employee. So the net effect, if I put these two particular statements underneath each other, this first one where the not is in the subquery limits the results to being those which are contained in table employee, whereas the second one where the not is in the where clause as opposed to the subquery doesn't so limit. The employee number starts at number 1. So that means that the first one, the results must be in table employee and table transaction, and they mustn't be 126 through 129, whereas the second one, the table employee number must be in table transaction and not 126 to 129. So it doesn't matter whether it's in table employee. I'm just saying we have numbers 126 through 129 in here, choose everything else. Whereas in the first one we're saying I only want you to choose those which are on table employee but not 126 through 129. So if you look at it in terms of joins, this first example is the equivalent to an inner join. And this second example is equivalent to a left join. So you can see how you can get radically different answers from very similar queries. So this is part of the reason why I like subjoins, because you can actually see what the answer is going to be in bits. I know that this one is giving me just these employee numbers, and I know that the second one is giving me everything but. Now it could be that your way of working might be that you prefer to use the joins, because now you can see it's going to be all of those which are on table transaction and where they exist in table employee, and you can see that the inner join is where they exist in both. But you need to understand the differences between the not in the subquery and the not out of the subquery. Otherwise, you will be making mistakes, unfortunately. Right, let's go back to our positive statement. We are looking for those transactions where the existing table employee, so in other words, this is the equivalent of the inner join, and the existing table transaction. So we have these 8 rows, and we're using in. Now there is another format you can use as opposed to in, and that is equal any. So what I'm saying is that I want the transaction number in table transaction to be equal to any of the following: 126, 127, 128, 129. And there we go. Now there is a synonym for any, and this may cause confusion. The synonym is sum, S-O-M-E. So the employee number is equal to sum of the following. That to me doesn't make as much sense. It sounds like it's got to be more than one, but it brings exactly the same results. Now, what if you want the opposite? If I go back to any, because I found that easier. So what if I wanted all of those employee numbers which are in table transaction which are not equal to 126 through 129? Well, let's change this equal to greater than or less than. Will that work? So we seem to have everything else. So if I scroll down, scroll up, and no, it includes employee numbers 126 to 129. So what's happening here? Well, the computer is going along quite nicely and saying, okay, employee number 1, is that not equal to any of 126, 127, 128, 129? That's fine. Employee 2, fine. Then we get to 126. Is that not equal to any of 126, 127, 128, 129? Well, we get to the first one. Is 126 not equal to 126? It is equal, so that's false. Okay, so we can strike that off the list. Is 126 not equal to 127? Well, it isn't equal to 127. So this turns out to be true, because 126 is equal to at least, or it's not equal to at least one of these. And similarly, when we get to 127, the fact that 127 is equal to this 127, right, that results in false, but because it's not equal to 126, because 127 is not equal to 128, 129, it results as true. So this does not work properly. What we need to do in this situation, where we are comparing one and making it not equal to all the others, is not use any, but to use all. So let's run this and see whether it works. So we scroll down and we can see that 126 through 129 are not there. So this time what it's saying is employee number 1 not equal to all of this lot? Well, it isn't. When we get to 126, is it not equal to all of this lot? Well, it's equal to one of them. So now it resolves as false. 127, is that not equal to all of this lot? Well, it's equal to one of them, so it's false. So it may seem counterintuitive, because you'd, in English, probably want to say is not equal to any of the following. But this time, in SQL Server, you have to use all. So it may help you to remember that any or some uses an or condition, and all uses an and condition. So we're saying, is 126 not equal to all of 127, 128, 129, etc.? Well, that's the equivalent of saying, is 126 not equal to 126? And is 126 not equal to 127? And is 126 not equal to that? And so what happens is that the first one resolves as false, and because that resolves as false, all the rest are equal to true, but it equals false. Whereas if we use any, then that is the equivalent of an or. And so we're saying, is 126 not equal to 126? That's right, it's false. No, it is not equal, so we get a false. Was 126 not equal to 127? That's true. And so false or true this time equals true. So that's the difference between any, some, and all. Any and some are exactly the same. All is the opposite. So you can see that all is quite often used with not equal to, or it's used with less than and greater than. It's just generally not used with equals, because 126 can't be equal to 126 and 127 and 128 and 129, whereas 126 can be equal to any of the following: 126 or 127, 128 or 129. And you don't just have to use equals or is not equal to, you could also use, say, less than or equals to. So let's have a think about what's going to happen. It's going to, because I'm using any, look into here and say 126, 127, 128, 129, and essentially it's going to say which is the highest of them, 129, because it's going to allow any numbers which are, and I'm going to take 0 as the base, though, because we're talking integers, it could be minus 2 billion, but so anything up to 126, or anything up to 127, or anything up to 128, or anything up to 129. So we could start at minus 2 billion. You could say 0 if you want to, but it does go from minus 2 billion. It just so happens that our employee numbers start at 0. So it will go from minus 2 billion, let's use that for accuracy, to 126, and it will also go from minus 2 billion to 127, 128, 129. So whether it fulfills any of those criteria, it will be true. So let's have a look at the answer, and so we can see it goes from 1 all the way to 129. Now if we did an all, then this or gets changed to an and. So any up to 126, and it's also got to be any up to 127, and it's also got to be anything up to 128, and it's also got to be anything up to 129. So if you think about it, the equivalent of the all, if I was to sum it up in one statement, would be any up to 129. It would be the loosest of all of the conditions, whereas that's for any, whereas for all it would be any up to 126. But so anything, let's call that, because I don't like to use the word any, because we've got any already. So what all does is tighten the conditions. It's got to fulfill every single one of them, so that's the equivalent of an and. Whereas any does the loosest of the conditions. So if I run this with an any clause, it's less than any of the following, and go right to the bottom, you'll see that it goes all the way up to 129. Whereas if I change this with an all, then you'll see that it only goes up to 126. So that is any, also known as some, and all. Right, we're going back to our original query where we're looking for the employee's last name to begin with a Y. And here you can see we've done it using the where clause. But what about if we curtail this table employee? Because at the moment, this table employee has got 1,005 employees. What if we curtail the table employee so that it is only those employees whose employee last name starts with a Y, and then join these 4 employees to table transaction? And we can do that in a subquery which creates a derived table. Now this is your derived table. So this is a complete table which we are going to use in a subquery. So we're going to replace the table employee here with this. So we don't need the where clause now. So all we do is we cut our statement and we put it in brackets in the inner join. So again, because it's a subquery, what we can do is we can run it independently. We see that it creates this table. We are then joining it to table transaction on employee number, and then we order it. So let's execute that. And there are our 8 results. Now it's important that you alias the table because this derived table has no name. It doesn't know that it's a table employee as its name. You could join it with other tables. You could join it with the department table, create a really complicated subquery, but that creates a derived table. But then what's the derived table's name? And you will get a syntactical error if you don't put the as alias. You can see it's expecting as. And there are a number of instances where you will have to name the resulting table, this being just one of them. So you might be thinking, okay, is this clearer? Is this not clearer? If I put my original select query there, which is better? And the answer is whichever is better for you. But is there one that the computer is going to calculate more quickly? Is it going to find that there are only 8 rows there and it's got to do less joining with the table transaction? Well, we're going to look at something that we're going to look at in a few sessions' time called the estimated query plan. The estimated execution plan, beg pardon. Now, there's going to be a lot to this, but I'm only going to look at one particular thing. This does not give you the results. This gives you how quickly how quickly a particular query is run, where the bottlenecks are, or what we're going to look at in this case, because I've got 2 queries highlighted, what the relative speed of the 2 queries are. So I'm going to press this button, the estimated execution plan, and you can see that this first query is 50% of the totality, and the second query therefore is also 50%. And just looking at the execution plans, they look identical. So what the computer does is it looks at your query and tries to calculate the most efficient way of calculating it. So these two, because they resolve as the same, are the same to the computer. So one isn't better than another in terms of this one will give you an advantage over that one. They're both the same. Now if I run the queries, you'll see that they give exactly the same number of rows, 8 in each, because they are the same. let's change it so that they're not the same. Instead of this inner join, we're going to do a left join in each. Now you might think that this will result in identical results. But let's think about this for a moment. Let's have a look at this second query. What it's going to do is it's going to take the totality of the transactions and it's going to left join it with the table employee. So we have the totality of the table transaction and those in table employee which are the same. We're then going to limit the lot by where the employee last name starts with a Y. So we have 8 rows. It just so happens that each employee in table transaction is in table employee. This first example now, where we have this derived table, is different. What it does is it takes table employee and reduces that by those employees whose last name begins with a Y. So instead of having 1005 employees, you will limit it to 4. So we now have this derived table which just has 4 employees, 4 rows. Now the outer query takes table transaction, which just as a reminder is 2000 and something rows. There are 2486 rows. It's going to join all of those 2486 rows with the 4 rows remaining in table employee, but it's going to keep all 2486 rows of table transaction because it's a left join. And that's it. There is then no where clause on this combined table. So let's just have a look at the results. We have 2486 rows. So we have the entirety of table transaction because that's not been filtered in any way. Now if you remember, in table transaction, in table employee, we have in both of them an employee number 123, but we have filtered out from table employee all the transactions apart from 126, 127, 128, 129. So we have the entirety of table transaction in these first 3 columns and then nulls for everything else other than these 4 employee numbers. So 2486 rows for this way and the other way 8. There's our 8 rows. So this is really where there is an important difference between doing it as a derived table and doing it in the where clause. One final point, nothing to do with subqueries, but you can see, we will be able to see it may have something to do. What if I change this where to an and? Okay, so now let's have a look at this anew. We are joining the table transaction to the entirety of table employee. We are connecting them where the table employee is equal in both, but we're keeping all the table transaction because it's a left join, and we're joining it where employee last name starts with a Y. So what is going to happen? Well, it is actually going to result in the same thing as we have with this derived table at the top. It is going to take a table employee and it's going to limit it to where employee last name it starts with a Y, and it's also limiting it to where the employee number is in the table transaction. So let's run this and we have our 2486 rows with all of these nulls. I do not like, personally, the and being used in the join section. There's a it looks ambiguous. I mean, it isn't. You can work it out, but there's a lot of working out. So I much prefer it being in where or being as a derived table. But to just let you know, it is possible to use and with constant or with likes or anything like this. You could say equals 5 and it will only take bring back well, if I choose a better example, 123, because that does exist, and that will limit what we get from table employee to 123. Have to use number rather than last name, obviously, like that. So if I run that, then we will have nulls for everything in table employee except for number 123. There it is. But I don't like it. I much prefer it if you have this in the where clause or using it as a subquery. I've just got to let you know it's possible. Right, well, we'll now move from subqueries in the from, and we've already done the where, into the select clause. Now, here we have a table with just 4 rows. These are the 4 employee numbers in the table employee, whose last name begins with the letter Y. Now, what about adding an extra column which counts the number of transactions in table transaction? Okay, so why don't you pause this video and try and work out how you do that. Right, well, here's my solution. And it looks very simple, doesn't it? Not. Here we have the number of transactions, but to do that we needed to do a join on table transaction. We needed to do group by because we've got a count, we've got an aggregate. It's much more complicated than what we had in just these first 3 rows. So let's see if we can simplify it using this count. So first of all, what are we trying to do? We're trying to count the number of transactions from table employee. So I'll just copy that into this. And right, so that is our figure. So what we need to do is insert that as a column in our select statement. So just to remind you of the figures, we have 3, 2, 1, 2. So let's put all of that, and we have to add brackets like that. So there's 2 froms, but one of them is included in the subquery, so it looks a bit complicated. So if you do an indent or put it on one line, right, let's see what we get. And there are 2 things wrong with this. The first thing is that we are getting the total number of transaction in table transaction, the entire table. And the second is that despite the fact we've got this as, there is no column name. So what we have to do is we have to alias the derived table outside of the brackets. And this is something that I will be repeating several times, and I'll highlight each time I do. You may have heard that now 3 times. So now let's have a look at this. Right, so now we've got num transactions as the column, but it's not actually linked to the row number. It's just giving us the same figure each time. So what to do? Well, we have this table E, and we have this table T. So we need to join them without actually using a join, because this is an independent thing. So if I wanted to say that I want each row to have the total number of transactions where the employee number is 126, then we can put where t.employee number equals 126. And there we are, we have 3. So what we do instead is we change this 126 to e.table employee number. Employee number, not table employee number, just employee number. Right, let's run that. And that gets us this answer with the 3212 that we were expecting. So now let's just have another look at what we've just done. We have an inner query, which is this one here, which is based on transaction table, which we've aliased as T. And we're saying that the T employee number is equal to the outer table employee number, the table employee. It's a bit like a chicken and egg situation now. We can't finish off this outer query without knowing the results of the inner query, and we can't do the inner query without knowing the outer query. What this is called is a correlated subquery. And what this means is that we can no longer run the inner query because it is now dependent on the outer query. If I try and just run this inner query, then we get an error saying we don't know what e.employee number is. But if you get it set up right so that the inner query just looks at a field that you've got in the outer query, then they correlate together. It substitutes in each running of this outer query the number that we get from the outer query in the inner query. So the subquery is executed repeatedly, once for each row selected by the outer query. So when we have the first row, what it's doing is saying select the count from table transaction where the employee number is equal to 126. In the second row, it's saying where it's equal to 127, 128, 129. So it links the two together without creating this formal join. And you can see that it's a lot less writing. We don't have to have this group by because there is now no aggregate. There is merely a subquery, but that's not an aggregate figure. Now, how far can we extend this? For instance, can we put the dates of the transactions in with this? So can we change that to t.date of transaction? Well, we can do it, but it won't run. So let's just have a look at that error message. SubQuery returned more than one value. This is not permitted when the subquery is used as an expression. And that makes sense, because what we're trying to do is add a column, not several rows. So whatever you do with these correlated subqueries, you've got to ensure that it only returns one answer. And so the easiest way to do that is to get it to have a min, max, some sort of aggregate. So a count, as I did previously. That only returns one value. Now notice that I don't have to alias the count, because what instead I have to do is alias the table. Now, can I sum the amount? Like that. Will that work? No, only one expression can be specified in the select list when there is a subquery. There is an exception with the word exists, but it's a very slight exception. And to be honest, exists asks, does the row exist, not a column exist? So it doesn't matter with exists if you've got 1 column, 10 columns, 100 columns. It just doesn't matter, it's just asking whether the row exists. So no, you can't do that. If you want that, then you have to introduce that as a separate column. So let's do that, select sum of amount, and we just copy the rest except for the comma. And we call that sum amount, total amount. There we go. Now it could be if you start to do lots and lots and lots of these that you'd be better off with the join in any case. Now, before leaving this subject, there is one question I've got. These two give the same result. So if I put them both, execute them both, you can see, apart from the columns, and if I want I'll actually make the columns identical, that they come up with exactly the same number of rows, and they will, after I've done this, come up with the same number of columns. But which is better? Well, let's find out from this display estimated execution plan. And this time we can see a difference. The first query only takes 1/3 of the time, the second query takes 2/3. So using this correlated subquery can be a lot quicker than having to do the formal join. So that's interesting, because what it's doing is it's only doing the select statement on 4 transactions, not all of them. Now what happens if I reverse this? So it's doing all of the others. And I run this. First of all, I'll get the right results, but then will I get the same correlated subquery being quicker? This time they're about the same, 49% to 51%. So you can see the major time saving is made when there is less to do for the repeated subqueries. Right, here's some questions. Right, the final thing with this section is to use a correlated subquery in the where clause. Now previously we've just used it in the from clause. So you can see this correlated query gives us the number of transactions and the total amount superimposed on top of the table employee. But what if we wanted it the other way around? We wanted all of the transactions and do a correlated subquery on the table employee. Well, this is where we use the where exists. So just to start this in perspective, we have 2,486 rows, but we only want that where there exists an employee number from table employee, where the employee last name is like Y%, and here's the correlation. The employee number in the outer query is equal to the employee number on the inner query. So that's the equivalent of the join, and you've got to have that inside. Otherwise, like we saw last time, where we didn't have this where, we just had the account of absolutely all of the table. We had to have this where to join it together so that we could just have, for each individual row, that one particular employee number going into the where. Here it's the same thing. For each particular row in the table transaction, we put into the where exists the table transaction dot employee number, and only select the employee number, or indeed anything, where it exists in the table transaction and the table employee on that row. So in other words, what's going to happen is that it's going to go into the first row and say, does it select this everything where it exists, that select employee number, that there is an employee number in table employee where the employee last name is Y%. Well, so far that exists. There does happen to exist at least one row where the employee last name starts with Y, and that the employee number is equal to the employee number in the row we're talking about. So the row we're talking about is this one, first one, with employee number 658. Does 658 exist in this small group? The answer is no. So that where exists becomes false, so it gets suppressed from the select statement because the where condition fails. So it goes down all of these. Now we can show this also as a extra column in the select criteria. So I'll put this as does it exist? And I'll just do something with the formatting. So this doesn't exclude them, but it puts a null where it doesn't exist, and where it does exist, it puts the employee number. So that's going to tell you that when it's in the where clause of this outer query, it's going to suppress them. It's not going to be part of the where. So let's put that back into the where exists. There it is. So now when we run this correlated query, we just get the 4 employee numbers and we get the 8 rows in which they exist. Now, it looks like a variant of the query that we started off in about lecture number 3 or lecture number 4 of this session 6. Is it any better in terms of speed? We saw that the correlated query in the select statement is quicker. So let's have a look. Display estimated execution plan? No. They both take the same amount of time. 50, 50. And that's understandable because what we had up here in the select is that it was only running 4 times. Whereas down here, it's running for every single row in table transaction. So what actually happens is that the computer evaluates that and sees it as identical to this second one. You'll see that the execution plan, or the estimated execution plan, is identical. So it works it out as being the same. So no, there is no faster answer here. So why am I telling you that this is possible? Well, simply because you don't know what you're going to be tested on, and I don't know what you're going to be tested on, and even if you weren't doing the exam, I don't know what you will come up against with somebody else's writing. It may simplify the process enormously if you use a where exists, but for instance here, you don't need this join. You just need this and instead. So it gives you the same things, just in different places, which you find easier to comprehend. And the advantage of this, of course, in using a subquery, is you can always execute it as long as you avoid the correlation. You can't run it with the correlation on its own as the inner query, because you'll get an error message. But it can help to clarify SQL Server. And anything that helps clarify TSQL has to be worth knowing. And finally, just a reminder that you can use not with exist as well. So here we've got all the table transaction up, only employee numbers 126 through 129, whereas we can put a not exists and have the entirety of table transaction, which was 2,486 rows, minus those 8 rows, so at 2,478 rows.